Hello, everyone. Okay, so let's move on to the second wet lab of the day. Right now, I'm going to go through data analysis of ERG, and I'm sharing with you my screen of our ERG View software. And in doing the data analysis, the ERG View software, like for us, is our items to basically take the raw data, present it into its waveforms, and provide a lot of tools to filter out noise from those ERGs, to measure those properly, and then to conduct comparative analysis of those ERGs, and basically be able to interpret the deltas between those ERGs as terms of what's going on with the eye. So what I'm going to show is a few example data. If I go here with our ERG View software, it's fairly simple to use. We're going to go to a PC session here, and I'm going to come up here to some compiled data here and show, say, for example, let's see if I can share a bigger screen. Is that possible? I'm noticing that not everything is showing up on the screen. Let me just grab some data. Here, example is a mouse that was done with photopic ERGs. So you can see here is all the tests that were results that were captured both A and B channels, so basically left and right eyes, and conducting a test. Okay, I see that you're only getting a partial view of this. Let me see if I can share a screen here differently. You share, let's try that. You see? Yeah, okay. All right. So we have it basically working here. Okay. Now, this is an interesting thing about these ERGs we're looking at. Starting at 10 millicandela, here was the left and right eye of a mouse photopic series. And you can see in these waveforms, sometimes we look at something, it looks like nothing. And a lot of times it is. But one of the things I wanted to point out was, as you look at this data, it's rather noisy. But even at a low light stimulus for photopics, the mouse ERGs are kind of all over the place. But as you actually increase the intensity of it, you can start seeing that there are some physiological changes that start showing up at around 300 millicandela in the mouse. So all of a sudden there's a little peak kind of showing up here, and you can see down in the B channel a little bit of definition is also starting to occur. But even when you get to further down and you start getting to 1 candela flashes, you can see, wow, all of a sudden very prominent ERGs are starting to come up. And you can see these look like more traditional photopic ERGs as you would see. And that's one of the things I just wanted to point it out, that you can see in the data. 1 second. 1 second. Drag this thing out of the way. You can see that you have a variety of data. Now, one of the things that you always want to do in looking at your data is want to make sure that if your computer is basically picking out a spot, is it picking out the same spot each and every time? If you look at these 3 candela flashes, you see these little biphasic peaks. And so right now you can see that the computer is picking either one of those spots. If for some reason it was not in the right alignment, you can always come in our software, come over, go to a measurement graph. And in here, you can actually come in and you can change the position of where is the peak and the minimum of the waveform. So this is something that is adjustable and then can be saved. And you can see then the update is then being captured in our software. And I'll do the same thing for this same waveform for the B channel. And I'll just scroll that over and put this on the second peak over here, just as an example. Okay, so now we are able to adjust. So that's a very important thing, is to review your data, make sure that your measurement positions are correct, and then save that data before you conduct any more analysis. Now, a couple other things you can do after analysis and the measurements is kind of look at the data comparatively. So one of the easy things to do is you can come in and say, let's take the A channel and let's put it into a comparison graph. And there, now I have a comparison graph that shows kind of the waveform. And now I can very easily grab additional waveforms and then overlay them and even show even closer comparison. I can align them at their flash point so you can see just in terms of timing and interval that the morphology of these waveforms is very, very close. But the only real difference is that the blue channel, the A channels, it has a little bit higher peak on the of the photopic hill here. But we can also do some other things where we can add even more ERGs to it. So let me just go ahead and put a couple more data points in here. So with going from the 3 candela and then putting them into the, from 3 candela to 10 candela. Now you can see another example where you're with that higher intensity, you start having an increase in the waveform as well. So these are things that you can quickly set up. I see that. Let me move this over here. I think you may be getting a little cut off here. There you go. All right, how's that look? All right, there's a good example. So now you have these waveforms. Now the last part, or the next part, is if this is data that you want to publish, we have the ability to come in here and put different thicknesses and different colorizations for each of the lines. So you can come in here at the green. We can make the size of this differently. We can make it a 6mm line if we'd like, make it fatter. We can use different symbols to highlight the different waveforms if we like. So there's a whole variety of ways to then take the data and after you've done your comparison to set it up that you want to use as evidence or for your experimentation assessment. Now, ERG View is a really good tool for doing graphics and for doing the data analysis, but sometimes you got to crunch a lot of data. And one of the things you're always able to do is that you can actually come into each one of these waveforms. You can do, have the ability to do the copy to, and we can save the data as XY text file information. So this can all be exported. So then you can then bring it into programs like MATLAB or Excel, and you can do additional analysis, data analysis outside of our system. So our system or any system that you're using, we want to have the ability to review the data in this manner. So that's one example. Let me show some other things. I just wanted to show you how with the mouse at low light intensity photopic, it looks like noise, but as the intensity gets to a certain point, then that photopic ERGs starts to show up. So I just wanted to show that as an example. All right, let me go grab some different data now. Screen sharing stopped as shared window is closed. Oh, sorry, let me screen share again. Okay, I'll share that screen. I have to do a PC session again. Let me grab some data. And 10. All right, so let's see. Here is some scotopic, some interesting sample data from a C57 scotopic mouse. So I'll select this data, hit open, and let me share the screen again so you can see the data. Let me try this, see if that works well. Okay, that looks much better. Now, what we're looking at is a dark adapted mouse, C57, and this is what we consider a very typical scotopic series. And in this circumstance, we started at 100 millicandela and proceeded all the way through from 100 to 300 to 1 candela, and then up to 3 candela, 10 candela, and on to 25. And what we have is then a progression of the ERGs. As you can see, these are very nice looking ERGs. There is very little noise in them. If there was some noise on all of them, we have the ability on a global level to filter that data. Our system has, and most systems do have, the ability to do certain notch filtering. In our system, we have a 60 hertz and a 50 hertz notch filter. We also have what we call spike filtering, which is basically looking at a change in data in a very, very short period. And we also do things such as low pass filtering. So we can set the top end of hertz that's being captured and presented. Currently, this low pass filtering is set at 150. But you can see even with a low pass filtering, it is still very, very, very clean data, even without any filtering being done. So one of the nice things you can do in this type of data, let me do a comparison. We can come in here to copy the test data to a comparison graph. And now we can open up this waveform. Let me come back over here and then I'll set it up. So now I'm going to grab all the B series. So I got B100, 100B, and let's go to 300B and grab that on here. And then let's go to the 1 candela. Then the 3 candela. $10 candela. And the 25. Okay, makes for a kind of a pretty little rainbow colors. So now everyone can see that this waveform. Now, this is kind of interesting for that analysis. As you can see, the lowest lighted stimulus was the B, this blue line right here, and it looks like this bright yellow was the highest intensity. So we can come through here and confirm that the 100 series is blue, and then we can scroll down here, we can see that the yellow was the 25. What I really wanted to highlight in here is if I come here and align these things at their flash point, you can see in a very pretty way that, you know, as the intensity increases, this eye must be functioning well because both the implicit times are happening faster, which is physiologically what you expect, and that the overall B wave, AB wave, is growing in intensity as well. So this is a good example of the type of close-knit data. And when you lay down these types of comparatives, you can very quickly see the physiological change that occurs. Now I'm looking here to see if there's any chat or any questions on the material I'm covering. So if you have any questions on, just go ahead and type those out, and we'd be happy to answer those. Okay. So that's let's see what other. Let me give you another example here. Again, of course when we're able to do things on a graph, we want to have some other ways of showing the data. So sometimes there's an interest in doing what is called a waterfall type of presentation. And in this circumstance, I'm going to set the voltage separation between each of the ERGs to say 300 microvolts. Let's see how that looks. And I apply that. Now you can see you got this interesting little waterfall. Where you have the B wave, the first wave at the bottom, and the progression going up. So however you would like to do analysis, there's a variety of ways you can do that as well. Let me cancel on that, bring it back to where it was. We can also just show graph onlys. We can put graph lines in here. So if you would like to capture any of these items in your analysis and wanted to drop it into an article, you have the ability here to simply come do a copy bitmap. And if I come to an app like Word, actually, let me bring that up. Okay, I'm going to try to answer here a question in just one moment. I'm going to show how I can copy the graph in here. And so as you get into your Word document, you can come in and do the paste sample. And then clearly you have now the ability to take this image and use it just like any other graphic and put it into your documentation. Now, our ERG view does have a couple reports that are built into it. One is this, for example, what we call our thumbnail summary. So this is something you can actually do the file and you can do the printout for this information. You can also do a look at our view, the summary page. And this summary page is pretty nice because this gives you all the quantified data of what's going on in a nice little table form. We also provide a B to A ratio in this little summary page. And you can print it from here, or you can even save this as text. And what does that do for you? That gives you a very common form that you can then import all this data into an Excel spreadsheet as well. So we try to make these things pretty simple to use. That's those are all really the key kind of components in the reporting side. Let me do one more. I'm going to read a question here and see how I can do to answer it. Can you compare also graphs from different measurements, like a baseline and end measurements of a study, or only the one within one measurement? Well, okay, so if I understand the question, it sounds like if I capture data today and then I want to capture data to, in 2 weeks, can I bring both of those together and then do an analysis so I can look at what's to change over the 2 weeks? If I understand the question, yes, we can do that. Let me walk through that with you just so you have an appreciation for that. Okay, let me close down a couple of these windows. Okay. All right, so come back here to the view session. Let me see, what's some good data to do this with? Okay, okay, let me take some data from one of our customers. I'm trying to think what they have in here. I think these might be just awake animals here, awake quick ret checks here. Yeah, so yeah, this is an example of a quick and dirty quick ret check, which looks really noisy, and is there really any data in that? Well, let's see what we can do on this. And then I'm going to tackle that, and then I'll come in and show a little comparison. When I'm looking at data like this, what can I make? Can I make it look better? Can I make it have more analytical sense to me? Well, let's start off by cleaning up this data. It's a lot of noise in here. See these spikes? So let's go ahead and go filter. Let's turn on spike filter. Oh, that really helped clean up these 2 waves right here. Let me describe to you what you're seeing. So this is a rods only 10 millicandela flash. So the intent is that in an awake animal, you're going to spend approximately, depending on the clinic, but I would say as an average of 10 to 20 minutes of dark adaptation. And that'll allow you to collect what is the B wave only. Well, there's a B wave in there. It's not the prettiest one, but you can definitely see from the flash time, there's a rise and a lowering that has kind of the indicative kind of bell curve that you see in a B wave. Then you can see a little bit of noise on the next one, which is the rod and cone 3 candela flash, which should give you what is a pretty traditional baseline A wave, B wave. And then the last is the high intensity rod and cone, which you can see is, pretty much the same thing, but you should evoke a bigger response. So that's what you're hoping to see. So we come here to filter. I basically have a 50 hertz filter on because this was done in Europe. And you can see that there was a lot of noise in that environment that was picking up in the mains. Well, that looks pretty ugly, but we can remove just that little notch and we can make them look a little bit more meaningful. Then what I can do is do a quick comparison. Or, hey, let's just say this is a repeat. Let's go through the question. Let's say I had this dog come back in 2 weeks, and I want to add to this session. So I'll add to the session. I will come back. I will find the data that I want to analyze. And I'm just going to pick some random stuff today here. Let's just see what's in here. Hopefully we get a decent looking, something that looks like a decent ERG. Oh, there's a little bit of a spike in here, but let's just work with this, okay? So now you have a week, 2 weeks ago, and this is what's run today. What you can quickly start doing is just do some analysis and say, is there much change? Now, these look like a little bit different waveforms. Well, what happens if I put them all on the same comparison graph and line them all up? So let's go through that. Put a comparison graph together, drag it over here. So that's the A channel. So let's do A channel to A channel, just see how that might turn out. Oh, let's see. So that has a very low waveform in there. So let's see, let's drag in the B channel. So you can see that the signal from that one line is very low compared to the other. So that probably tells me this might actually have be more flat than anything. But let's pull up another one and see what happens here. So now I am in the scenario taking two different time sets. I'm overlaying the data, and I can start seeing that when I start putting those over, that there is a significant difference between the sets of data. Now, normally it would have one waveform look fairly close to the other, but you may see a reduction in the intensity or the timing may change. Those are the types of things that you would see over a period of time. I hope that answers your question. So I think if there's any other questions, please send them to us, and I will try to answer them. And while I'm waiting for other questions, let me go through one more analysis here. Let's see what I've got here to show. Let's see. Okay, let's look at some rabbit data. Okay, this is a rabbit data. This is actually a very good example of data that was captured in research. The rabbits were subject to a treatment and control, left eye, right eye. It was blind to the study of what the treatments were or which eye. And we basically conducted what were the ISIF protocols on the rabbits. So let me just grab some of that data and we'll see how that looks. Okay, so as I was saying, we're using the ISIF protocol, and the ISIF protocol is basically starts off with a rod-only flash, and then you can see the standard rod and cone flashes, both eyes, then high-intensity rod and cone, followed by cones only, which there is a 10-minute light adaptation period that's fixed between the high intensity rod and cones and the cone onlys, and then it is finished off with flickers. So let's do some analysis of those different types of flashes. Different time. Sure. Okay. Yes. Okay. Let me come through here, and I'm going to do some quick analysis, and then I'm going to go back to comparison graphs right here at the end. All right, so let's look at the rod. So now we can do a comparison of left eye, right eye. And I can quickly look through here, and I can see that, you know, my points where the B waves are being captured look fairly close, a little difference in timing on some of them. You know, this B channel and this B channel look pretty similar. Looks like a little bit of a lag on the A channel. So let's go ahead and do an analysis. So starting with the rods, right click on that. I'm going to copy that to the comparison graph. So there is channel A, and let's just drop in channel B and see how close those look together. Well, it looks like one has a little stronger signal than another. Let's go ahead and put that align at graph at the flash point on there. Now you start seeing maybe a little difference between the left eye, right eye. Well, let's go on that a little further. Let's drop in the rod and cones. So put the 3 candela in there. This is the AI, the A. I'm going to make this a little bigger for everyone to see. That's the A. Now we need the B. Okay, so it looks like the green is the B channel. So the A has a little less of a A wave than the B wave, or the B channel. Let's do this one more time. Let's do the rod and cone. Get it? So now we can start seeing that there is a little bit of change over time. So that way is you can start doing this comparison, and now from that analysis you can start seeing that one channel seems to, in all different intensities, has a little bit of a difference in the implicit time as well as the intensity. So you're showing there's some difference between the two eyes from the treatment and control. Okay, now question to come back at looking at the comparison graph again. And the question was looking at different time points. Okay, let me see if I can come up with something that shows a little bit better time point data here. Let's see. Kind of wish I had the time point data for these rabbits. That would have been perfect. But I only have one date point in there. Let's see. Under 240 here. Let's see. This is going to be all right. Let's see if I take. All right, a little bit of noisy data. Now this is a quick rec check test. And here is one set that was done. Let's see, I may not have a separation in date here. Let me see if I can add to this session. And let me come down here and scroll down. Yeah, I think I'm going to only have one date set here. So I think we're going to have to, we're going to look at this from a difference in the time between probably how much dark adaptation occurred on this particular animal. So they were both done based same time, but with a couple more minutes difference in the timing. So this would be something of an example. Well, first, let's go through the process of, you know, are the points basically being picked about the same? Well, maybe. Let's get rid of these spikes and see what happens. Cleans up a little bit of that noise. You can clearly start seeing B waves as well as A wave and B waves, even though this is awake and a little bit noisy data. And let's just see what happens if we put a notch filter on. Nope, doesn't really help it. Doesn't really improve it that much. So I think we can live with that noise. I think you can clearly see the morphology, so we can just work with that. Now I'm seeing here, there's a little bit of an artifact, and it looks like in fact, it may be picking up the artifact at the top. So let's go adjust those. So I go copy test data and go to the measurement graph. Yep, see it's sitting here right on the top of this thing. So that's kind of throwing it off. And in this circumstance, since we're sitting on this artifact, I would recommend that we try to pick a point that is going to be fairly close to a peak other than the artifact. So probably I'm going to come into this top point. What I'm going to really note is the time that I pick right there at 50. 52, implicit time 52, because I'm going to pick the other artifact off the other artifact, and I'm going to use that same point as well. So at least I'm using the time interval to look at what intensity is occurring. I'm going to close that. And then I'll come back here and fix this one. Copy test data to the measurement graph. And again, I'm going to take this off of that peak point, come down here to 50. Okay, and close that one down. So now we have a bit more relevant data to compare. So let's just say, let's see what type of change happened over time between the A channel here for the 3 candela and then later on. So I'll right click this, put a comparison graph together, set up, move over a little bit, and then throw in this comparative graph and then overlay them. So you can see that, you know, they're fairly close in morphology, but that second flash a couple minutes later yielded a little stronger 8-wave effect. Let me come back in here. And I could do the same thing for the, let's look at the B wave. Let's just do the B wave only. So there's the first wave, here's the second. Do a comparison on those and line a flash point. So you can see that one B wave is definitely, the black B wave is creating a bit more B wave intensity than the previous. So does that give, I hope that gives you some idea of the examples of the comparisons over time. And let's see. Good question here. I'm gonna read the question. In an animal model, mainly with RGC, retina ganglion cell damage, what ERG protocol do you suggest, and what endpoints do you use in that data analysis? That is a good question that I would like. I'm going to give you my opinion, but that's also a very good question, and I would like us maybe to come back and cover at the Q&A session tomorrow with Ron Ofrey on the line and Joe McClellan, and let's talk about that on how do you pick the right protocols, the right type of testing to target on your cells. Just want to make sure that that's clear. On the retina ganglion cells, I know that there are ways of testing ganglion cell functionality. Pattern ERG is definitely one of the things that looks at the RGCs. Full field flash, that is something we can talk to Ron about what you can really get out of the RGCs as to the other types of methods of ERG, multifocal, what can you get from those different cellular constructs. So let's definitely put that into a question for Saturday. But thank you, that's a good question. We're just gonna review here. Are any other, yeah, so how long do we keep the mouse in the dark room before conducting ERGs? There are, I think typically I hear overnight, 8 hours is being what most people do as a standard. And I think that probably makes the most amount of sense. Most importantly, whatever you do in your lab, do it consistently. If it's 10 hours for one group and you're coming back to test them again, do the same 10 hours. Try to keep all those variables as low as possible. Try to be consistent. That will yield you better data. Okay. Let's see, any other questions we might have? Let me see. Yes, overnight dark adaptation is the norm, but yeah, it depends on just when you're going to start your studies as well. Okay, what protocol settings do you suggest for assessing RPE functionality? So RPE, that's getting a signal construct for the RPE functionality. It's going to be something, again, as a good question to be asked with Ron in the room and covering some of those aspects of what you can get on looking at functionality in RPE. Keep in mind that full field flash is a summary of photoreceptor response. And that's basically the summation. Now, in different types of flash in different scenarios, we're able to ilk out different cellular contributions to those waveforms. So that is one of the things that I would like us to make sure that in our conversations at the Q&A session is made clear to you, so that when you're trying to decide on what protocols, what type of electrophysiology you need to conduct to be most supportive of your research, that's what I want to make sure you've got a good sense of by the end of this course. Okay, I think there are also some things in the lectures and the videos that also address these points as well. Okay, let's see. Got a question. Can I set my own ERG program protocol in the program? Answer is yes. In our software, we do have a add-on package. It's called ERG Tran. ERG Tran allows any user to create any type of full field flash number of testings of that, and then having different sequences of tests all put together with the timing intervals. If you need background adaptation, all those things can be added in, so you have a consistent test from beginning to end that you can use on all your animals. That's definitely a powerful tool to have for conducting research. Okay, I'm going to ask, do you have any other questions I can answer at this time, or anything else I can show you on data analysis? If there are no further questions here, I would like to go ahead and we'll go ahead and complete this wet lab session, and then resume back on our 1 o'clock schedule to do large animal ERG. And we're going to do 2 types. We're going to do, we're in the process of sedating a rabbit, and we will conduct ERGs on the sedated animal. And we're also going to do that doing bilateral ERGs. So this is a good example of how you would do any type of sedated small or companion size animal, rabbit or a little bit larger. And then we will do an awake dog, just like you would see come into a clinic, and we'll be using my pet neuron for that particular conduct that particular exam, as well as the rabbit. Scarlet is also one of my pets, so we'll be taking good care of her. We're going to sedate her, and then we'll come back and here in say about 15 minutes at 1 o'clock, and we will resume our discussion in our wet labs. I'm just going to make sure one more time. Any other questions? Looks like we're doing okay. So I'm going to go ahead and I'm going to sign off, and I will see you all in just about 15 minutes. Okay, thank you.
If you should need any assistance with the course, technology, or any problem, please feel free to email us at info@acu-science.com or call us at 866-250-3937, extension 6, and we'll be happy to help you. Thank you again for attending our course.